All right, well, good morning. My name is Stephen Ezel. I am the Vice President of Global Innovation Policy at ITIF, and thank you for joining us for our second panel this morning entitled, Can Technology Revive U.S. Manufacturing? So, if we can go ahead and get started, I'll take about 5 minutes to set the table with some framing remarks before introducing our panelists and turning the conversation over to them. So, as we discussed on the previous panel, whether you call it smart manufacturing, Industry 4.0, or the industrial internet, the reality is that information and communications technologies are in the midst of fundamentally transforming modern manufacturing systems and processes. These ICTs include technologies such as high-performance computing, computer-aided design, the industrial Internet of Things paired with advanced sensors, wireless connectivity, cloud computing, 3D printing, industrial robotics, big data analytics, artificial intelligence, and machine learning. These advanced technologies even include new forms of advanced materials and composites and biofabrication processes. Collectively, these technologies are transforming how consumer and industrial products are being researched, developed, and designed, how products are being fabricated and assembled, how factories and supply chains operate and integrate, and even how products are consumed and used post-sale. In fact, fully 25% of inputs into modern manufacturing processes are comprised of digital services. And we see a number of examples of how this is transforming companies. If you look at Ford Motor, for example, it has sensor-enabled virtually every piece of manufacturing production equipment at its River Rouge plant outside Detroit. On the factory line, downstream pieces of machinery can tell if a work piece is coming down the line is off in even the slightest fraction of a dimension, so they can instantaneously detect faults upstream in the manufacturing process and facilitate predictive and preventative maintenance. They track humidity and temperature conditions inside the factory. So if it's inappropriate when they are painting a vehicle, they can either change the environmental conditions or move the workpiece somewhere else in the factory. In fact, one US automaker estimates that its implementation of the industrial Internet of Things combined with big data analytics has saved it $2 billion in operational cost over the past 5 years, a return on investment of over 400% on the approximately $350 million investment they made. My colleague Tim Shinbara and I had the joy of being invited by the Austrian government last year to take a tour of Austria Industry 4.0 to see how their manufacturers were implementing smart manufacturing technologies. And we visited a automotive brake pad and gear shift manufacturer in Linz, Austria called Miebe AG. And we got the tour of the factory floors. Machines are literally spinning off brake pads. They're going to go into the BMW i8. And this crusty old Austrian engineer stops at one of these machines and pounds his fist down. And he said, now, you understand, BMW wants or has demanded that this machine be integrated seamlessly into their combat information center in Munich, Germany, because they want to know the real-time status of every single piece of production equipment in BMW's 6,000 major BMW i8 suppliers, so they can know in real time what is the operational status of all the equipment in our entire supply chain across Europe. So where this is going in the future is the ability of entire industrial supply chains to be able to connect, to complexively adapt in real time, and ensuring that we have the capacity to enroll small manufacturers in these technologies is going to become vital for nations and complex supply chains to compete. When you put all the math together, analysts find that smart manufacturing has the potential to increase the productivity of the world's factories by 25% over the next decade. Some estimate this could add as much as $10 trillion to global GDP over the next 20 years. We expect to see reductions in safety accidents by 25%, 25% improvements in energy efficiency. So manufacturers will become more productive, efficient, and innovative. But perhaps more profoundly, smart manufacturing technologies are poised to fundamentally alter the landscape of global manufacturing, increasingly enabling competitive manufacturing in higher cost environments, in part by heralding an era of mass customization and reducing efficient production lot sizes. If you think about it, previous manufacturing technology transitions had the effect of concentrating mass production manufacturing at economies of scale in low-cost labor locations, chiefly offshore in Asia. But as smart manufacturing boosts productivity, labor costs relative to total cost can diminish, making at-the-margin manufacturing easier to locate in higher-cost areas. Smart manufacturing can also increase needed skill levels on the factory floor, making traditional locations and lower-wage locations potentially less competitive. Moreover, as American companies adopt a more comprehensive total cost of ownership, TCO analysis approach, they're increasingly finding that rising offshore labor rates, combined with other hidden cost of offshoring, may counterbalance any remaining savings from cheap price or labor abroad. I think they've also increasingly discovered that separating research and development from manufacturing has had a negative impact on the innovation process. In conclusion, the digitalization of manufacturing potentially holds a tremendous future. Industry and enterprise will lead this transformation, but if we don't get the policy environment right, then neither will consumers and society be able to enjoy the benefits of these technologies, but also it will impede the ability of a nation's enterprises to effectively compete in the global smart manufacturing era. So we need to put in place the right policies to facilitate this transition. And our panelists today are going to amplify and extend upon these remarks and talk to us about where's America's strongest and weakest in development and application of these technologies, what are the barriers to adoption and implementation, and what do governments need to do. So first we will hear from Mr. Mike Molnar. Mike is the founding director of the Office of Advanced Manufacturing at NIST. Mike has served as a manufacturing policy fellow in the White House Office of Science and Technology Policy and spent many years in leadership positions in industry, including at Cummins Engines. Mike has an executive MBA from Notre Dame and bachelor's in mechanical engineering. We'll next hear from Tim Shinbara down at the end. Tim is the Vice President for Technology at AMT, the Association for Manufacturing Technology, where he's responsible for the Information Technology and Manufacturing Technology departments. Tim has done yeoman's work in spearheading MT Connect, which is probably the world's leading initiative, I'd argue, to help machine interoperability so we can understand the data we're passing between machines. He has over 16 years of technology development and implementation experience. Next, we'll hear from Dave Vasco. Dave is the Director of Advanced Technology at Rockwell Automation, where he's responsible for applied R&D and global product standards and regulations. Dave serves as a member of the NIST Visiting Committee on Advanced Technology, or VCAT, and is on the boards of the Smart Manufacturing Leadership Council in the Milwaukee Institute. Last but not least, by any means, Elizabeth Fikes, who was the Director of Product Supply Engineering for Procter & Gamble. She has worked in the US and China, leading global and regional organizations on initiative launches, engineering project execution, and supply chain management. Her current role focuses on enabling P&G's over 2,000 engineers to deliver projects with excellence across all business sectors. So with that, let me turn the floor over to Mike. Thank you, Mike.
Well, terrific. Good morning, everyone. Today I am representing not only NIST, but the Advanced Manufacturing National Program Office, this interagency team that was called for to be a whole-of-government effort on these public-private partnerships. And thank you for that generous introduction. You know, it's interesting. He didn't mention my master's degree, and the whole point of that master's degree was in the 80s, we were all convinced that Japan would eat our lunch. And this was a call for advanced manufacturing technologies, and we need to get better in quality, and we did. We rise to the challenge every time in the United States. It takes us a while to recognize these challenges, and today, for the past several years, including a number of organizations, and I would say most especially ITIF, have been doing this clarion call about it's really the innovation. It's about technologies. It's not, don't think about manufacturing as this macroeconomic thing of labor cost and interest rates and such. It's really the story about technology and innovation. And we couldn't agree more. And this is why for over a quarter century, my role in industry was advancing, taking technology, making it robust, putting it on the shop floor, designing and building plants. And I have to tell you, it's not about labor costs. We created an advanced manufacturing plant here in the United States, recognizing the technologies that we had could not be sustained in these other countries, and we closed those down, moved it to the United States, because the story there in advanced fuel systems is about technology. And that's really, Rob has incredible timing, because my story today isn't to talk about policy needs, because we've been talking about this. I'm an engineer, and we've been talking about things a long time. What have we been doing about it? And we've been actually quite busy. So his timing is impeccable. I bring gifts. I'm going to represent what's happened with the Manufacturing USA program, and less than an hour and a half ago, we've released our annual report. So this is on manufacturingusa.com. I just wanted to cover brief highlights of this, as well as tried to get copies of these for all of you, but couldn't get that turned around. But we are bringing copies of the National Academies Workshop. So in short, I wanted to very, very briefly cover what's been happening here. And if you haven't been aware of Manufacturing USA, this is now will be a 3-year-old program that's joined at the hip with our 28-year-old national network called Manufacturing Extension Partnership. In short, with this, advanced manufacturing is the nexus of innovation. The U.S. still absolutely leads the world in discovery and innovation, and yet we are lagging behind in scaling these things up, de-risking, making robust, getting it on the shop floor, and more, if the supply base isn't here, even if the large company has a technology, their supply base is not here. So what this is about, and a third point, which ITIF has made many times, if the challenge is huge, individual companies, universities, even federal agencies can't get these. The most effective means to address these game-changing technologies, get them across, is public-private partnerships that are led by industry. So, going to what's in this? Well, there's 3 external references. This is a very august time, because this is one of them. I wanted to briefly highlight what happened with this. We also had Deloitte. And there's the data is also in here, summarized very nicely. So the Deloitte was the view of the private sector, industry, and academia. We also, this year, had the voice of the public sector. The Government Accountability Office, GAO, did an assessment of the Manufacturing USA program. And then finally, so 1, 2, and then 3 is the external, and this is our report. So where are we today? If you are new to it, it's only 3 years old. It was this is authorized under the December 2014 Revitalize American Manufacturing and Innovation Act, or RAMI. If you are used to it, then the notion is this has been around a long, long time. What have we done? Just to show you, we now have 14 institutes. 6 of them were launched this year in 2017. So this is very, very new. And you mentioned 2025, the China plan. Imitation is the sincerest form of flattery, because they copied exactly. And the 2025 goal is 40 institutes by 2025. And they've launched 2 last year. They're launching 3 this year, and the topics are exactly what the U.S. has launched. So we're taking that as great flattery. What are these public-private partnerships? They're industry-led. The government's role is to set it up, that neutral convening ground. This is TRL 4 to 7, pre-competitive. So this is the exciting thing. In my industry career, it was very difficult to work with a university, even harder to work with 5 universities at the same time. Hard to work with other companies, and impossible to work with direct competitors. That's what you can do in a Manufacturing USA Institute is it's the pre-competitive collaboration space. So really quick about this report, released now 90 minutes ago. Well, it has all 8 objectives of the REMI Act are covered. We highlight these in 4 specific things. One is, are we creating impact to the U.S. manufacturing innovation ecosystem? And as of last year, 830 companies and universities were members. So MIT is one, Rockwell Collins is another. That would be 2 of the 830. The exciting thing is 2/3 of those are small and medium-sized enterprises. This is really good, because this is the source of innovative ideas, and yet these are the people that find it most difficult to develop this technology and get it across the goal line. Financial leverage is the second one, and in 2016, roughly $114 million of public monies were invested in these 8 institutes, and that was matched by approximately 2 to 1, which is unheard of in any other country. So this has really catalyzed something. 3, I won't try to get into this, but nearly 200 major technology projects were underway, and they're very, very exciting. These are talked about in this report, but real ones like American icons like John Deere citing, with this revolutionary advance in silicon carbide, we have leapfrogged. We've developed this power inverter, and our hybrid excavators, we're building a plant in North Dakota to make these for worldwide export. So these are the good things that are happening already, even though the program is so new. 4th is the development of a manufacturing workforce, and just even though the program is new, over 28,000 people were touched by the 8 institutes last year. So quick snapshot, I hope you take a look, and this is available now on manufacturingusa.com. Let me just briefly talk about these external responses. Deloitte did a study, and 830 members. We did not anticipate that 120 of those members would find value in being members of more than one institute. That was great, but if you take a look in this, and if folks don't have a copy, we have more, but what we didn't anticipate, even the institute directors didn't realize how much that this is creating that tipping point, creating the manufacturing clusters. Rob is right. It's all about the clusters, and we're forming these clusters, and that's the undergirds, the supply chain in U.S. manufacturing. So of the 120, well, we didn't anticipate that last year that catalyzed over 9,400 connections between companies and universities doing projects, even outside of institutes, and that's what we want to see. So even though it's new, over 9,400 connections were made on companies working together on advanced projects. Deloitte also made recommendations on metrics, and we've implemented those. Turn quickly to GAO. GAO said the program is meeting its objectives, and they had one major finding: we need to engage even more agencies. So in addition to the Department of Commerce, Department of Defense, Department of Energy, NASA, NSF, Department of Education, and USDA, we need to have all 8 federal agencies that have a role in advanced manufacturing be a part of Manufacturing USA. So we have very pleased to announce that we've added the Department of Labor and the Department of Health and Human Services, specifically FDA and BARDA, as part of the interagency working team. So two quick assessments that are important data points, and these are available on our website. One final point, another initiative, 28-year-old national network called Manufacturing Extension Partnership. We have an embedding program. Every institute, every one of the institutes has an MEP representative, and the goal of that, because MEP is the conduit to small and mediums, we want to have small and mediums tap into what's happening at these institutes. This study was meant to, and boy, this dovetails into what Rob teed up, 5 objectives. Examine the external reviews, provide an in-depth discussion of the particular institutes, address the contribution of institutes to workforce and economic development. It's the technology and the workforce. Describe how other nations are supporting advanced manufacturing, and you heard it in the first panel, and then discuss potential U.S. priorities and policies for action. So I'd like to call your attention to that. So in conclusion, We're very excited on behalf of the interagency team. 3 years now, second annual report just out. Manufacturing USA is successfully achieving its program goals. We are convening a diverse array of members and coordinating project activities. Small business is highly engaged, and that was an important focus for us. And finally, as you take a look at the Deloitte report, they're showing conservatively a 5-to-1 advantage for why companies are involved with Manufacturing USA. So thank you very much. And if I didn't mention it enough, manufacturingusa.com, we have a little report that we're awfully proud of.
Well, thanks very much, Mike. It's heartening to hear about the progress at Manufacturing USA and how these 14 institutes of manufacturing innovation are just doing a fantastic job of moving innovative manufacturing process and product technologies from laboratory proof of concept to actual implementation on the factory floors across America. So thank you. You know, Rob, if there's a person in this room who I think could beat Clyde and you on mileage, it's probably Tim Shimbara, because I've never emailed Tim when I haven't got a response of in Brazil or China, I'll get back to you. He's really an individual who has been on the ground seeing the evolution of smart manufacturing technologies around the world, and I think has an interesting perspective on where the U.S. has strengths and weaknesses in this new environment. So, Tim, the floor is yours.
Yeah, I appreciate it. Stephen, is it okay if I just do it from here?
Yeah.
Is that all right? All right. Good morning, guys. I appreciate the opportunity. This discussion is probably going to be fruitful on both ends, so if I say something that incites some emotion, that's good. The truth of the matter, when we're going around, AMT that is, when we're going around the world, and we've got 4 technical centers, Monterrey, Mexico, Sao Paulo, Brazil, Chennai, India, Shanghai, China, offices in Beijing and Poland, we have an interesting insight into what moves and what doesn't. One thing we do when we find those movements is we compare it to what the U.S. is doing. And can the U.S. do better? Is there comparative advantage? Is there competition? What's going on? 2 main things have come to the forefront of our minds when we look at the U.S. And in the industry in general, and that's the manufacturing and the manufacturing technology industries. There is a data-centric environment that has now become the norm. Folks who just produce things have value to those things, and that's good. What we're finding is that the secondary and tertiary value that used to be data is now primary almost, even over sometimes even the function of that part, because services, as Stephen alluded to, have a much bigger play in GDP than just the initial product itself, which is a little bit concerning to some, but it's an opportunity to others. So that data-centric environment is coupled with another thing we're finding, and that's going to be around the cross-section and cross-pollination of technologies. So the way we look at this in the U.S. is the normal ecosystem of innovation in the manufacturing technology world would normally come vertically. That means a company would have their own R&D labs, they have a particular problem, they meet it with their particular expertise. Folks out of Silicon Valley and Austin and Boston and RDU, all these places are now starting to play in that innovation game. The tools that we see are going to be advancing our manufacturing world tend to look more like CS and IT more than they do OT, operational technology. So if we think in our manufacturing technology space that we're alone and we're fine and we're going to incrementally be better and still compete, we are grossly wrong. How that plays out as far as the cross-pollination goes is something that AMT are trying to get ahead of. So we have things where we actually do mission boards of our AMT board members to Silicon Valley, not to Chennai or Bengaluru, not to Shanghai, but into our own quote-unquote backyard. Because what we see is a huge disruption coming from people not in our space today, and they see the opportunity of putting value on data. So when I look at some of that, one of the things that we look into as far as strengths and opportunities go, and I like, I believe, Rob, you mentioned it earlier, if you say the word challenge, people think, oh, we're incompetent or something else we need. This is really not a challenge, but an opportunity for the U.S. because we have comparative advantage when you start talking around CS and IT stuff. But what we consider our key strengths, I would say, is the connecting of this data-centric ecosystem. So if data is important, if porting that data is important, which is the MT Connect world, so 30 seconds, that's a semantic dictionary. So if you collect data, that's great. grossly insufficient for value. Just because you've collected it doesn't tell you what to do with it. If you look across all the industrial IoT world, that is very much disparate data, speaking different languages. Italy in the room today. I actually have a chance to meet with the Italian Trade Agency next week in Houston for some things. But think of the United Nations trying to explain stuff, and we don't use any kind of translation devices, and you're just using your native tongue. That's exactly the world of the industrial IoT. MT Connect is a semantic dictionary that is that translator, right? So we see that happening. But so we see a strength in the U.S. about connecting that data-centric ecosystem, and we certainly see a strength in material development. An additive is in the headlines quite a bit, and there's reasons why, and I'm glad for that and hope it stays there. There's a lot of stuff going on, even at scale. When you start talking nanomaterials and things that we do for functionality and embedded functionality, designed, engineered functionality. Materials have a huge play in the U.S., and we have a very strong competitive advantage because of things like the ICME, the Integrated Computational Materials Engineering work. So simulation and all these other things that we understand very well applied to materials. The third thing I'd say is the innovative designs and the usage of manufacturing technology. The U.S. is still the biggest consumer of manufacturing technology, second to China, obviously. One thing on the Made in China 2025, we've been following that very closely, as you might expect. I think the percentage is upwards of 80% or more of that is to meet Chinese domestic demand, not necessarily primarily to go take over the world of manufacturing. They have a huge demand that they're just trying to meet themselves. Anyway, that being said, the U.S. definitely leads in the innovation of using and consuming such manufacturing technology. So taking something and making more out of it. You could get towards the world of productivity, if you will. But we still have some opportunities, I think. Even though I mentioned additive as a good thing for the U.S., and we did start the first patents and all that good stuff, very early race with Germany, we're not necessarily leaders across the board in additive. But we have the ecosystem to maintain that or to accelerate out in that, especially in the metals and especially in hybrid. But we have to pay attention to this. This is why I like the word opportunity over challenge, because an opportunity means you're being intentional. And that was the inference Rob was making earlier, is that it's not just going to happen. But if we see this stuff, we can be intentional about it. On the machine side, the machine control itself, we've been writing G code for decades. Not much improvement in G code. For those who don't understand, it's just what tells the machine to do something. It's a very antiquated way to command machines to do something. There's better ways in programming, especially we talk about the CS flavor of things, of how to get controls to be more open and scalable. The third thing, and I'll end on this, is the robotic interoperability. It's no longer just the term advanced robotics. It's no longer the term that we can just have better, more effective axes and range of motions and all this stuff. It's end effectors, it's intelligence, it's cobots, it's all these things. So it's how the robot interacts with things, not just that you have an advanced robot, right? Which gets back to a very basic business valuation statement. So we're seeing a lot of that, and especially in the autonomy. So let's go back to the CS world, then I'll close, Steve. And that's what's really pushing a lot of this stuff: data, AI, and machine learning. And that is going to be, if you think about that in the manufacturing technology space, we think that's the biggest accelerants, if you will, to get the U.S. ahead in competitiveness as far as manufacturing is concerned in the goods and the data that we produce. Thanks.
Thanks, Tim. That was great. Now let's hear from the company perspective with Dave and Liz.
Sure. So I guess the challenge here is, can the technology revive manufacturing? And the technology by itself, no. But there are things we need to do really to encourage this. The technology can provide a tailwind to really help us do this. So I'm going to talk about 3 technologies that I think are important. I'm going to talk about some of the national initiatives and the landscape we're playing in. And I'm going to talk about the workforce issues here and why it's so important for the workforce development and some of the hurdles we're facing there. So I work for Rockwell Automation. We're the world's largest company dedicated to industrial automation and control. Been in this field for 114 years. When we are involved, and we have the privilege of serving our customers because of innovation and understanding their domain, their needs, and that's part of where we're coming from. We see the technologies that are emerging today helping with flexibility, and that's going to help a lot of things be reshored back in the United States. Because of the flexibility, you're going to do more and more things here to order, more customization. That shipping time back and forth is going to become more of a blockage to actually producing things. So actually having things done here will give shorter times, lead times, to actually getting these custom products, and the flexibility will help that. The technology I think that are important are, first, we hear a lot about big data, and we've always had data in manufacturing. We've been interconnected in manufacturing for decades. All the manufacturers have. It's a matter of getting that data out and actually using it. So it's really the analytics, the machine learning, building upon that. We've always been able to put a PhD on a particular problem and find a solution. That's always been there. It's not been cost effective to make that happen. What's happening now is with machine learning and the analytics, it's a lot easier to see the trends out there. I'll give you an example. We're approached by a large company in food and beverage that produces coffee. And they have drying machines. And these drying machines will dry out the coffee, and at a certain point, the vapors will contaminate the machines. And they're finding that 40% of the times the machines were down for cleaning. 40% of the times. They have hundreds of these lines. So they have more than 100 extra lines just for downtime to clean the machines. So we actually put some machine learning algorithms on this. We're able to determine that there's a huge difference between the fouling rate for caffeinated and decaffeinated. We learned what the fouling rate was. We could actually observe what was happening with individual beans coming through and determine precisely when the machine needed to be cleaned, take it offline, clean it for the mixture of coffee that was there, and bring it back again. Huge improvement. And that's just analytics done, machine learning done very, very close to the machine. We also use data analytics to look at every one of the lines worldwide for that manufacturer so they could say, how are the machines performing worldwide? Who's following the procedures, who isn't? And that's we're going to see those things be applied easier than ever before. That's going to create additional value for this customer did, because it allowed them to produce a lot more coffee with less resources. The other thing we're seeing is, with all this data, if we were to now present more data, 100 times, 1,000 times more data, what are people going to do with it? It has to be formatted. So we have to have technologies like virtual reality, augmented reality, mixed reality, visualizations, wearables. These are going to provide a way to provide the information people need when they need it, and just in the context they're in, based upon their role and what they're doing at the time. That's going to be crucial to really making this data actionable, be able to actually do something with it and to gain value from that. And then finally, the third technology is really collaborative robotics. So we see, if you go into a plant today, most of the robotics are behind guarding systems. And if a person were to walk past the guarding system, the robot would stop. It takes a lot of time to get those systems up, installed, debugged, working, and it takes a lot of time to do changeovers. You're seeing a trend more to collaborative robots. And for the next 2 decades, you'll see that, and it will probably transition completely into collaborative robots at some point. The collaborative robots really provide an opportunity to be very, very flexible, to have the operators involved, to have the operators actually help to train the robots for repetitive operations or operations that ergonomically would be very difficult to do. And that's going to help a lot with flexibility. There's been cases where they've added collaborative robots, the workforce has actually gone up, and it's worth them to increase the workforce because the changeover times have gone down, the flexibility is increased. So those are just 3 of the technologies. I didn't mention networking. I mean, obviously, wireless, and cellular networks are advancing. Cloud is advancing, but those technologies are becoming more mature and not as much as a game-changing technology. They're just an enabler as we go forward. The national initiatives, so we talked about China 2025, we talked about, there's ones in Germany, Industry 4.0, we talked about Manufacturing USA. There's some 30-plus national initiatives we follow throughout the world. The vast majority of them are working very hard to make their country competitive and to take a competitive advantage there, and maybe even specifying what needs to be done for their manufacturers. The U.S. has taken a different approach. So in the U.S., we don't believe in picking the winners. We believe in putting a lot of innovators together, finding the best solution, and letting it emerge. So it's a little different way of approaching it. We wouldn't have Google or Amazon or Microsoft if we didn't believe in this innovation. but it is a bit of a headwind for us to follow, and not everybody is always playing fair. We need to realize it. And then finally, the talent. I think Luke had mentioned the talent. What's the talent issues? With all these technologies, if we don't have the people that can use these technologies, we're going to be not able to take advantage of this. We're losing, I think it was last figure I saw, about 400,000 baby boomers a year are stepping out of the workforce. These are the people that have been in our manufacturing plants that have the skills, and they're being replaced with a lot of innovative new people coming in. The millennials grew up with laptops. The Gen Zers grew up with tablets and smartphones. I mean, you probably have seen the YouTube video of a 2-year-old trying to swipe a magazine because they knew how to use a tablet better than they knew how to use a magazine. So there's a lot of people coming in, but we need to be able to help to skill the workforce. And Luke was asking, what can we do to do this? We're working on a government program with the government now, actually with veterans now, with manpower to actually skill workers. A lot of veterans, when they leave the workforce, they've had high-tech jobs, but they have not been able to fully employ themselves. They're underemployed in the workforce. So we actually have a program right now where we actually will train veterans, and 12-week program, and we actually cram about 4 months worth of training into that 12-week program, and there's a job waiting for them at the end. And the question was, what do you need to do? Well, if we asked those veterans to pay for that course and pay for their expenses, they could never do that. So we actually pay for the veterans to pay for the training, we pay for them to be in the course. At the end of the day, they actually have a job waiting. Some of them have tripled their salary in actually doing that. But there needs to be some incentives to help them along to make that transition. And without those incentives, we're not going to have the workforce we need to leverage these technologies to be competitive.
Thanks very much, Dave. And I love that point about how if you add collaborative robots, then the workforce grows up. There's a great study done by Greats and Michaels the other day from LSE, London School of Economics, found that it's been the countries with the lowest rates of industrial robot adoption that have had the highest rates of manufacturing job loss over the past 15 years, those being UK and Spain. If you don't have the most cutting edge technology, then the company's just going to go out of business. With that, Elizabeth.
Great. Hey, good morning, everyone. I have to tell you, I was smiling at your veteran story because that's a key focused recruiting area for P&G as well, getting our veterans to work. So, good morning. My name's Elizabeth Fikes. I'll give you a little bit of education background. I am an engineer. I've got my bachelor's and master's in engineering from the University of Illinois, and I've been an engineer at P&G for over 20 years. You all mostly have, I'm sure most of you have, P&G products in your home. We've got everything from Crest to Gillette, Old Spice, Olay, Pampers, et cetera. So we're fairly well known. We're very known as a marketing company with great consumer products that deliver superior consumer experiences. But I also want to try and talk to you a little bit about our supply chain and our manufacturing excellence, because that's something else that we also see as a huge competitive advantage that Procter & Gamble has. Gartner, that kind of grades supply chains on how excellent they are, has created a new category as of 2015 about who are supply chain masters, and they put P&G and Apple into that group, and as of 2017 they added Amazon. So they kind of single out just a few companies globally that they think are kind of tops when it comes to supply chain, and P&G is proud to be one of those. We are a local manufacturer. You know, we have operations in 80 countries, but we really do try to be as local as possible. With the types of products we produce, you really can't afford to ship them across oceans. You know, so if I am making Tide, I need to make it as close to the consumer as possible. If I am making, you know, Bounty paper towels, for instance, I really can't afford and still put them on the shelf at just $1 or $2 each to have them have much shipping cost. So we are biased to be as local as possible in our manufacturing, and that's something we believe in. So I love the comment on China. If we're going to serve Chinese consumers, we have to do it out of Chinese plants. If we're going to serve U.S. consumers, it has to be out of U.S. plants. So with that said, we have 25 plants or production facilities in the United States that P&G runs. Most of them are large. You know, they're spread across the United States, and that means that 90% of what we sell in the U.S. is actually made here in the U.S. We also bias that our suppliers to these plants, the companies, small, medium, as well as large manufacturers that provide raw materials and pack materials to us, also need to be as local as possible. The name of the game for us is, of course, cost, sustainability, quality, all the things you get when you have kind of short transportation between goods into our plants. But it is also about synchronization. And the work we are doing now on synchronizing our supply chain, local suppliers feeding a nearby plant, and those plants are close enough to where our retailers are and close enough to consumers. That helps us with the time element. Because as much as consumers really want a great product at a great price, they're also getting quite particular that they want it on their timing. They want it on their doorstep or on their porch overnight, or even sometimes faster than overnight. Or when they go to a store for shipping, to actually go shopping, they want to have everything on shelf. So as important as cost and quality and sustainability is to us at P&G, synchronization and time to market is one of our new rallying cries, and that makes us really excited about what advanced manufacturing can continue to do for our supply chain, deliver lower cost, while also helping us synchronize and take days out of our supply chain so we can be more responsive. So that's our name of the game. We are a global company. We've got 120 plants, but we're again, U.S. headquartered, right? So we have a significant number of resources working in the United States that support our global operations. So 1 in 5 of our US-based jobs is actually doing work for our international operations. So we actually carry well more than our fair share of headcount here in the US. Because again, we have global R&D centers here. In fact, my role is a global role. I own global capital management, so all of our CapEx that we spend as P&G, as well as health, safety, and environment, in addition to having some operational things I do specifically for the United States. So we really do try to, as a U.S. company, put a lot of jobs here that support the globe. Our advanced manufacturing vision for P&G is called Factory of the Future. No surprise, I think everyone's got a Factory of the Future. But what's a little different about ours is we have tried to keep the worker at the center of this model. So it's a Factory of the Future vision that still has a worker-centric element to it. Key to our production capabilities is the fact that we want every employee at P&G to operate as an owner, regardless of what level they are. P&G is a very old company, 180 years old, one of the first companies in the world to offer any type of a profit-sharing program to all levels of the company. And we allow that to kind of keep us focused, that as much as our Factory of the Future is about digitization and automation and industrial IoT and all these technologies, it's also about the worker. It's about making them more capable, more productive, so we drive more value from our manufacturing operations. I'm going to use a quick example here, which is of a diaper, because I think Rob must have said diaper 5 times last night at dinner. So how many of you have put a diaper on a baby lately?
How about today?
In the room? Today? Oh, congratulations. You're going to help me with this. So how many materials go into a diaper that are unique? 30.
Wow.
Okay, so 30 diapers, or 30 materials come together to make this size 4 diaper. Handles about a 20-pound baby.
One material fills it.
Yes.
Over another. Yeah, too.
So, but the fun of this is we're bringing 30 different materials together. A lot of these materials are coming from these small and medium manufacturers, right, to us. Human hands don't put this together, and they haven't for a very, very long time. We have high-speed converters that put these materials together. There's elastics, there's cuffs, there's nonwovens. There are these little materials we call AGM, absorbent gel materials, that capture the fluid. They keep it from smelling bad. They let a baby be comfortable and crawl around in this, whether it's been used or not, for quite a while, and help keep the skin dry and protected. We do this work of making this diaper on a converter in a single stream at 1,000 a minute. 1,000 a minute. So when we even find a defect in one, the speed with which the milliseconds we have to reject the one that is bad is just incredible. I mean, it's kind of a feat of mechanical engineering, and we got some ASME people here. It's fabulous to stand and watch a diaper converter.
What's the machines?
We are P&G designed and then fabricated, because again, we can't buy a machine that does this, so we make our own. We design our own, and for years and years and years and years. So we have continued to innovate on the product, which drove the process transformations, which drives the equipment design and the controls, right? So after the final knife, when this is actually becoming now a discrete individual diaper, it still looks like it's one long chain, because again, at 1,000 a minute, it's a blur going down the line. Now, the fun of this, too, is that we want data on a per diaper basis. We want to make sure the AGM little beads went in all the right places. So we're using sensors and cameras and imaging and taking about 15 to 20 different quality measurements on every single diaper at those rates. So there's a lot of science and engineering. I tell people this is the most engineered garment they'll probably ever wear in their lives, right? Now, I might be proven wrong as we come up with some of these other wearables that we're designing that can get to all your biometrics and stuff. But this is our challenge, and that's just one of our many products that we're working on. So hence, it's easy to understand that we need cloud computing. What are we going to do with all this data we're collecting on the eaches? The interoperability of our industrial IoT. How does the different parts of the equipment communicate? How does it take quality data and recenterline itself? We have flexible robotics. So while the machine or the converter that makes the diaper might be a very specialized machine that makes this diaper only in a few different sizes, we also have the dynamic, though, that the material feeds to the line. The takeaway after the line are done by much more flexible robotic systems, cobots that can load materials, et cetera. So just to kind of give you a highlight of those. What we're really asking for, though, from this broader community is how do we create, we don't call it clusters, but ecosystems. Ecosystems that combine academia with industry, with government, so that we can actually come up with more solutions that can drive not just the cost down and drive the value of manufacturing up, but also the speed. How do we change this product and put something new and better on the shelf even faster? How do we deliver this to market, whether, again, it is an e-commerce play or whether it's into our retailers? So some specific things that we are, of course, excited about is we do need continued help on IP protection. You know, we spend a lot of time both in patent work as well as trade secrets, making sure we can put the best product possible on the shelf at the right cost structure and do that all around the world. Our converters that make these are the same, whether the converters in Lavera, Brazil, whether it's in Cape Girardeau, Missouri. We're starting up a diaper operation in our Utah plant in Salt Lake City that'll come online in 2018. We've got plants in Japan, in Akashi, that make diapers, plants in China, plants in Euskirchen, Germany. So it's the same converter everywhere. We need it protected everywhere and in good partnership. And then the other thing I'll play into is that our science and technology investments have to continue to encourage STEM education programs. We partner with all of our local community colleges because when we build a plant, we often stay there for a very long time. We've got great community relations between our local partners in academia. We'd love to see more help there. Thank you.
Great, thank you so much, Elizabeth. And P&G is another great example of benefiting from public-private partnerships. I understand that your collaborations with national laboratories in working with high-performance computing to solve complex fluid dynamics problems has added $1.2 billion. So that's been great. I want to ask one quick question, then turn it over to the audience, so get your questions ready. But talking beforehand, particularly with Tim and Dave, y'all had some interesting perspectives, I thought, about the strengths and weaknesses of countries' Industry 4.0 or smart manufacturing strategies and what they were trying to achieve. I wonder if you could just amplify those insights a little bit.
Yeah, sure. I'll kick it off, Dave, and you can come on in. So if you look at it as a spectrum of policies, and there are 30 plus each country, and they all kind of have a make or made in their titles. If you take Germany as an example, that's a very prescriptive way of doing things. So they define, I'll use the word standard loosely here, so lowercase s standard. They'll define a standard of how you're going to get data, what you're going to do to physically interface, how you're going to move up the hierarchy of that data and to have something that's useful. And they describe very explicitly the type of technology, where to find that technology, da-da-da-da-da. On the other side of that spectrum would be more of a diagnostic view of it. So let's give you what we consider the minimum or the sufficient minimum of data or technology, and then you figure out market, you figure out how best to utilize it. And that's more what the US is looking like. So if you take a real example of this in reality, you have the Fraunhofer Institutes, in which they do a lot of test beds and a lot of very closed structured, and they have a very nice unitized solution that comes out of that. And it takes a while. In the US, you could use the Industrial Internet Consortium model. They also use test beds. It's very ad hoc, Tiger Team based. They fail fast, fail many times, but eventually something comes out and people say, oh, that makes the most sense. It happens more quickly, but you have more, if you will, negative headlines. These members fell out because they didn't go the direction they thought it would help their company. These stayed in, the technology changed. Oh, but now we have something. But what they've done in the IIC test bed model, which is different than the German model, is they've said, we will raise visibility on the things we think are most important. And then we'll give you plug-and-play interoperability tools to go figure out if it's important for you, and if so, what you do with it. Germany's a little bit different. They say, we will tell you what your problem is, and we'll tell you how to solve it, and by the way, go buy the solution here. Thank you, German government. Both work in certain cultures and certain markets. Both have challenges, not necessarily equally in the same way. Both have challenges if they become a global solution. So when we look at all of this stuff, the one thing that's key across all of this is the interoperability part. So Elizabeth and others, David hit it as well. If data is key, then the interoperability and the usability of that data is paramount. And that's a little bit of perspective that we see.
Sure. So I agree that the Industry 4.0, the German effort is very prescriptive. It also, if you look at the landscape they've mapped out the OT, the operation technology, the IT information technology, and how to connect those. If you look at the work that's being done, though, it actually only addresses about a third of that landscape. They do mostly the OT. They don't do a lot of the connectivity in between. They do very little about actually using the data, how it be used. And they try to come up with an approach where you build up from the start. And I think it's very different than the U.S. approach. I think we've advocated, there's a lot of technologies out there today. You can make differences today in applying these technologies. You don't have to wait for everything to be complete. And in fact, if you look at a lot of the technologies that are being developed today, in 5 years, some of them will run their complete course. And if you were to wait 5 years before you actually had things in place, you're going to miss out on a lot of the opportunities. So I think that's maybe a fault in the German system, is that it doesn't allow this growth, and it doesn't allow a lot of the innovation that can occur. China's looking to pull a lot of the stuff in. They're pulling a lot of the stuff in. We've seen even from the IEC making national standards, and we're encouraging them to take the work they're doing, the extensions they've had, and bring them back to the international community. We don't want to be in a situation where, as a manufacturer, we would have to deliver multiple different products or services for different countries. It would just be impossible to do.
And I asked that to amplify the point earlier about how the U.S. and Europe and others can learn from one another. I want to open it to the audience for questions. If you would please raise your hand, state your name and who you're with. Why don't we do this, because time is short. Let's take 2 or 3 at once, and then we can have the panel respond. We'll start up here in the front, if we could. We'll take 3. I see 3 now, so we'll take those 3. And let you all respond.
Morning, ladies and gentlemen. My name is Rosemary Segura. I'm a president of a company called Segura's International Group. We focus on small and medium businesses in manufacturing, and also now we are working with universities, engineering students. Mr. Vasco, my business was a coffee till and a roaster. I used to roast coffee on the round machine.
Please may I ask you to ask your question quickly, yes, so we can accommodate everyone.
How can we work with you and all of you with the small and medium businesses and students? Do you have some programs in your institutions?
Great, and I think that's something Mike can help answer. Let's then go to the side and to the back, and we'll take those questions together. Thank you.
Yeah, I'm Yu Binguo from the Advanced Manufacturing National Program Office, and I have a question, Beth. So the first event talk about the manufacturing GDP get a lot of concerns in U.S. But of course, there are the manufacturers who contribute to this decline. So technology, culture, operation model. And another thing I would like to know is how the manufacturing capacity in each company is accounted to manufacturing GDP. It's counted like, because outsourcing generate a lot of company international. It's counted the U.S. GDP or other countries' GDP, or just a double counted. So that might affect the GDP ratio as manufacturing activity.
Okay, thank you. And then one more in the back.
Art Chambers, U.S. International Trade Commission. You guys talked a lot about the importance of data in the manufacturing process, in the supply chains, and the aftermarket services that get bundled with your products. And I'm wondering, to what extent do policy measures in other countries that either restrict data flows or force data localization or other cybersecurity measures affect your company's abilities to manufacture and to innovate?
Great. Mike, why don't you take the SME one? The companies can take the data flows, and y'all can collectively answer that.
Well, great. I think you heard this from Dr. Singerman, but small and medium-sized enterprises, of the 250,000 manufacturing companies in the United States, 249,000 plus are small and medium-sized enterprises that are critically important. And this is why, starting in 1989, we formed the Manufacturing Extension Partnership Program. This is a public-private partnership. There are centers in each and every state. And so the short answer to that is MEP centers. They provide free information, they provide low-cost help and consulting, and they can work with any company on a mission for domestic and also to be more competitive with developing and creating and selling internationally. I think and just touch on the last question, where you make it matters. And this is why if you're going to be competitive, it's about the technology and it's about productivity. So where you make it does matter, and that's why MEP is focused on supporting the small and mediums.
And just one data point, we have 11,000 US-based suppliers, P&G. So we count on small and medium as well as the Rockwells of the world. Large suppliers all the way down to small and medium.
Did you want to comment, Dave? Or Tim, about data flows?
So data flows, so yeah, I could talk about data flows. Actually, this is a critical issue for us because some countries, particularly China in particular, is restricting data flow, data out of the country, and that's really, so we don't know how this will affect us. It's actually the uncertainty in doing business that's causing us the issues there. It really hasn't been worked out all the way. We've seen how some people have approached it, but it's a concern, and where the line will be drawn is causing uncertainty in business.
McKinsey had a nice study the other day looking at the output of data by industry. New data for 2016 shows that globally manufacturing produces twice as much data as the second closest industry, which is actually finance, and more than government, more than any other sector. So manufacturers fundamentally depend upon the ability to move data seamlessly across the world, both for the internal operations of the business, but also for the ability to deliver the business model to the consumer. Talk about power by the hour, how they price guaranteed thruster uptime for jet engines. You can only do that if you're able to communicate data as the plane moves throughout the world. We have a report recently called Cross-Border Data Flows, What Are the Barriers and What Are the Costs, which identified 56 precise policy data localization policies that 34 countries around the world have put in place. So happy to refer you to that report, both for a good inventory of what these data localization policies are and specific economic estimates of what they're costing the countries that put them in place. Because the reality is, especially for SMEs, studies show that it can raise the cost of access to cloud computing services by as much as 60%. So really, countries are only harming themselves when they put these types of policies in place. Mike?
Yeah, I think, and this dovetails into the last question, but I really love the stories, and as the father of 3 children who would buy the Pampers in the largest possible box, it's an amazing product, but it wouldn't matter if they were $5 a diaper. And so Elizabeth did something I'm not surprised of, which is make even what you think is the most mundane product today as remarkable. If you go to the shop floor anywhere in the world, you will be amazed at what you see. And as they say, any sufficiently advanced technology looks like magic to the uninformed. The point of this is they realize product and process, you cannot separate them. So if you are a company that went asset light and you don't have technologies related to your process, and you're buying your technologies only from the machine tool builders, well, everyone can do that. So the name of the game, and this is where the data comes in. The revolution that they're talking about with this Industry 4.0 is about, if you consider this, the thing in your pocket, if you have a smartphone, has 6 sensors. The typical machine tool, not Elizabeth's amazing 1,000 a minute, the typical machine tool on a shop floor in the United States has 600 sensors. And what we're doing right now is connecting them, making them smart. And so this is a tremendous opportunity. It's also tremendous risk related to cybersecurity. So those people that are talking about this manufacturing revolution at hand, it will be all about the data, and there is so much more upside. The United States is positioned better than any other country to really leverage this, and this is where interoperability and data security, and this is why NIST plays an important role with interoperability and the cybersecurity framework.
And to add to that point, we have talked here about how these modern manufacturing processes will allow mass customization, lower production lot sizes of one, enabling companies to fill production closer to final market demand. And Tim, you talked about China with Made in China 2025 wants 80% local service, and I think the key point to make here, and we see that when you look at the growth in global manufacturing trade over the past decade, it has grown more slowly than global economic growth, than even global trade in total when you include services, as we are seeing more production occurring closer to final demand. But the key point is that competition and trade and economic exchange be conducted truly on market-based terms in accordance with the WTO principles of national treatment, non-discrimination, reciprocity. Doesn't matter that that Made in 2025 wants to service 80% of China's market demand. China is part of the WTO now. It needs to allow 100% of its markets for consumer and commercial to be open to businesses to supply those markets no matter where they are in the world, and let them do so based on the economics of where they can most efficiently manufacture products and put them in front of markets. And I think that's got to be remembered in the discussion of how technologies can affect trade and manufacturing. Let's take one more question, and then or two, and we'll wrap it up with those final two questions.
Well,
Alberto and Phil.
yeah, David or Elizabeth, I'm fascinated by this the veterans program. I'm really fascinated. Now, because I've been watching all this commercial through my life, and you enroll in the Navy, in the Army, we're going to teach you this, we're going to teach you that. And so I always wonder, how does that work in the end? Yeah. So maybe there's nothing, there's something that everybody knows. So you can answer me in private. I don't want to make anybody waste time.
I'll give you a veteran's perspective after we close out for the day, if you like. That's where I came from.
So one thing that we've struggled with when veterans come out, their skills aren't directly mapped many times to the commercial world. They have a lot of high-tech skills, but there's a lack in mapping them to the world or to the needs. They've had tremendous amount of responsibility at a very early age. So if we can provide them the skills they need to map into the environment, it makes it very easy for them to get involved. And they pick them up very quickly. Like we say, we train them about 4 months worth of activities in a 12-week period. So they're very quick at picking things up. But it's a matter of doing that mapping to help them get that mapping so that people in industry will see them as being immediately valuable to their organization.
And a lot of our mapping happens because we have a good alumni network of veterans already in our companies, as you do, right? Which helps with that. Younger veterans coming in, helping translate and map those skills.
And just
the transition.
What is the average age?
25 to 30 for us.
Okay.
Yeah.
And just by the way, if you haven't seen it, the Digital Manufacturing Design and Innovation Institute, one of the 14 institutes of manufacturing innovation, has just released a wonderful report called a Digital Taxonomy of digital design roles in the modern economy that categorizes 165 different skill sets and roles in the smart manufacturing ecosystem. It's a great inventory of what jobs and what skills are out there for smart manufacturing.
And the last question. So you do this program because it's great for you, not for civic responsibility, not because you feel.
So we do it because it's great for our customers.
Okay.
So the graduates go to our customers. Yeah.
Thank you so much.
Yep.
All right. With that, please let me thank you all for coming today. Please join me in thanking our wonderful panelists.